Welcome to the podcast on data visualization tools and techniques. The podcast is part of the data analytics series. In this podcast, we will explore data field types, which define how data is structured and represented in visualizations. Understanding these field types is essential for choosing the right visualization techniques, ensuring accuracy, and effectively communicating insights. The current podcast is created by Jitendra Tomar, an academician and experienced training consultant with a passion for knowledge sharing and skill development. With years of expertise in education, corporate training, and professional development, he intends to bring insightful discussions and valuable perspectives to the learners. This podcast is designed at JT Design Studio, a creative hub committed to producing high-quality, engaging, educational content that resonates with learners and professionals alike. Let us explore various data field types used in modeling the data. In data visualization, a field type refers to the classification of data into specific categories or types based on its nature and characteristics. These classifications help determine how the data should be structured, processed, analyzed, and visualized to extract meaningful insights. Different types of data require different visualization techniques to represent them accurately. For example, numerical data is best suited for charts like bar graphs and scatter plots, whereas categorical data is more effectively represented using pie charts or grouped bar charts. By correctly identifying and assigning the appropriate field type to each dataset, data analysts and visualization designers can enhance readability, improve data accuracy, and ensure effective communication of key insights. A poor understanding of field types can lead to misinterpretation, incorrect visual representation, and ultimately, flawed decision-making. To visualize data effectively, it is crucial to classify it correctly based on its characteristics. The given are the most common field types used in data visualization. Let us explore each one of these one by one.
Categorical fields represent distinct groups or categories that classify data into non-numerical segments. These fields are commonly used for grouping and comparison in data visualization. Examples include gender classifications such as male, female, and non-binary, product categories like electronics, clothing, and furniture, and regional divisions such as North, South, East, and West. Since categorical data is best understood through comparisons and distributions, effective visualization techniques include bar charts for comparing category sizes, pie charts for showing proportional relationships, and tree maps for displaying hierarchical structures. Numerical fields represent quantitative data that can be measured or counted, making them essential for statistical analysis and mathematical computations. These fields can be classified into two subtypes: continuous data, which includes infinite values and fractional measurements such as temperature and height, and discrete data, which consist of countable, finite values like the number of items sold. Common examples of numerical data include sales amounts, temperature readings, and population figures. To effectively visualize numerical fields, techniques such as line charts are used for tracking trends over time. Histograms help in understanding data distribution. Scatter plots are ideal for identifying relationships between variables, and other statistical methods provide deeper insights into numerical patterns. Temporal fields represent time-based data and are crucial for analyzing trends, forecasting, and tracking changes over periods. These fields include specific timestamps such as dates, like the 10th of December 2023, times, like 10:30 a.m., and broader time divisions like years, months, or days. Temporal data is best visualized using time series charts, which show changes over time, Gantt charts, which illustrate project timelines, and calendar heat maps, which highlight patterns based on date-specific data such as website traffic or seasonal sales trends. By leveraging these techniques, temporal data can reveal insights into historical trends, periodic behaviors, and future projections. Spatial fields represent geographical or spatial data, allowing users to analyze and visualize location-based trends. This data type includes coordinates, such as latitude and longitude, addresses, and geographical divisions such as country or city names. Spatial fields are commonly used in mapping applications, urban planning, and logistics. The most effective visualization techniques for spatial data include choropleth maps, which use color gradients to represent data intensity across regions. Bubble maps, which highlight varying data points across locations, and heat maps, which indicate density or concentration of data in a given area. More advanced applications may also use 3D spatial visualizations for a richer geographical analysis. Textual fields contain unstructured or qualitative data, which includes customer reviews, comments, and names. Unlike numerical or categorical data, textual data does not fit into predefined structures and often requires processing techniques such as natural language processing, NLP, to extract meaningful insights. Effective visualization techniques for textual fields include word clouds, which highlight frequently used words in a dataset, text networks, which show relationships between different words or phrases, and sentiment analysis visualizations, which categorize text based on emotional tone, helping businesses and analysts gauge public opinion and customer feedback. Boolean fields are binary data types that can take only two possible values, such as true, false, yes, no, or 0 or 1. These fields are commonly used for status indicators, logical operations, and filtering criteria. Examples include active status, whether a user is online or offline, and subscription status, whether a customer is subscribed or unsubscribed. Since Boolean data represents categorical divisions with only two choices, pie charts are useful for illustrating proportions between the two categories, while grouped bar charts can provide comparisons across different groups or time frames. Hierarchical fields represent data structures with parent-child relationships, making them essential for visualizing complex relationships and nested data structures. Examples include organizational charts, which display reporting structures within a company, file systems, which show folder and subfolder relationships, and taxonomies, which classify items into categories and subcategories. The best visualization techniques for hierarchical data include tree maps, which use nested rectangles to represent data proportions. Sunburst charts, which display hierarchical relationships in a circular format, and hierarchical node graphs, which visually connect different entities in a branching structure. These visualizations help users understand complex relationships, spot patterns, and navigate structured datasets efficiently. Understanding field types in data visualization is essential for selecting the right techniques to represent data accurately and effectively. By categorizing data correctly, whether numerical, categorical, temporal, spatial, textual, Boolean, or hierarchical, analysts can unlock deeper insights and make data-driven decisions with clarity. Leveraging appropriate visualizations enhances interpretation, enabling better storytelling and impactful communication. Let us see why is understanding field types critical in data visualization. The first reason is that it helps in choosing appropriate visualization. Understanding field types is essential for selecting the most effective visualization techniques that accurately represent the data. Different types of data require specific visual formats to convey information clearly and meaningfully. For example, Numerical data is best displayed using line charts, histograms, or scatter plots, while categorical data is better represented using bar charts, pie charts, or tree maps. Temporal data, which deals with time-based trends, is effectively visualized using time series charts or Gantt charts. By correctly classifying data, analysts can avoid confusion and ensure that the chosen visual representation enhances comprehension rather than distorting the message. The second reason is to ensure accuracy. Using the correct field type prevents data misrepresentation and enhances the credibility of visual insights. When inappropriate chart types are used, data can become misleading, resulting in flawed interpretations and poor decision making. For example, applying a line chart to categorical data might incorrectly suggest a trend when no such relationship exists, while using a pie chart for too many categories can make comparisons difficult. Ensuring accuracy means not only selecting the right visualization but also maintaining consistency in data representation, helping audiences trust and understand the information presented. And the third reason is to simplify analysis. Proper classification of data fields streamlines data aggregation, filtering, and insights generation, making analysis more efficient and meaningful. For instance, numerical fields can be summed, averaged, or used for statistical analysis, while categorical fields are useful for grouping and comparison. Temporal fields enable time-based trend analysis, and hierarchical fields allow structured data navigation. By accurately classifying data, analysts can perform deeper analyses, uncover patterns, and draw actionable conclusions with minimal errors. This ultimately enhances decision-making by ensuring that insights are derived from well-structured and properly categorized data. Understanding field types is crucial for selecting the right visualization techniques, ensuring data accuracy, and simplifying analysis. Proper classification prevents misrepresentation, enhances data aggregation, and enables clearer insights, leading to more effective decision-making and meaningful visual storytelling. This brings us to the end of this podcast on data visualization tools and techniques covering the intricacies of data field types. The podcast is part of Data Analytics series. Always remember, learning is an art and is a lifelong scholastic activity. Hope to be with you in some other session, some other time. For more academic content on various subjects, remain connected.